All right, thanks for joining. My name's John, senior software engineer with over 10 years of experience, interested in helping you land your first or next programming role. And I am doing job search prep. We're doing the Leetcode kata, and we might do some other things. So today we're going to focus on depth first search and breadth first search. DFS and BFS. So in the Leetcode kata, we can start with an offset. Clone graph, all right. Then we could go on to course schedule. What I'd like to do is mix it up, if we have time, to go outside of the kata. And that's because I did a practice interview recently. Used Interview Kickstart. It went really well. And they gave me some homework. They recommended that I do 2-city scheduling. Unfortunately, this is not DFS or BFS, so we might not get to this. But another little bird told me that Minesweeper is good prep at one of the companies I'm interested in. And that one is, if I recall, DFS, BFS. So I want to focus on these like homework assignments that I got. And so the way I'm incorporating that with the kata is that we'll jump over there basically and break the kata. So we'll go over here first, do clone graph. And then I think after clone graph, we'll switch over to Minesweeper. Okay. I don't know that I want to dive right into clone graph. I guess I should, right? So part of me is like, let me warm up with linked list cycle just because I've been doing it recently. It's a pretty different pattern. Let's do that just as a warm up. And because palindrome linked list is one that I should practice. It's one of the tougher ones. How do you keep your head cool before a technical interview? The kata is a cheat code for that. By familiarizing yourself with a set of problems, you can calm yourself and put yourself in the right mental model for a coding interview just by doing a couple of those problems. And by the way, I don't go through the whole 12 standard kata or even the whole 20 kata. I don't go through that typically the day of, but I'll do a few problems on my own before the warm-up. So I typically do like 45 minutes. So I'll start getting ready for the interview about an hour and a half before the interview. If it's on site, get physically on site or whatever. Hydrate, food, make sure you're fed. Do not over caffeinate. Have a little bit of caffeine, a little bit of maybe theanine, green tea or whatever. So hydrate, food, nutrition, cognitive supplements, whatever. Then I'll try to get through 3 problems. If I can get through them in 30 minutes or less, that's great. I'll give it up to 45 minutes. I'll time box myself there. And then I want to have 15 minutes of just quiet. 15 minutes where I'm just kind of like still resting, preparing that way. So that's basically my hour and a half warm up for a coding round in practice. Okay, let's dive into linked list cycle. Hopefully this is quick. All right. So given the head of a linked list, let's determine if it has a cycle in it. We can see example 1, what is a cycle? You're continuing along the linked list and you end up looping. So it's like an infinite loop in linked list form is a cycle. And if there is a cycle, we want to return true, otherwise return false. All right. So time complexity. I need to explore n+1 nodes to see if I loop. So you have to check every node, and then you need to go beyond the last node, at least one more, to know if you're looping. Space complexity. I can use a node cache, easy mode. The harder thing, that's easy mode at O of n. The harder thing is to use fast and slow pointers with in-place second half list mutation for O1 space complexity. And if you notice this problem isn't easy, it's because they think you're doing this easy mode up here. So if you do what I'm mentioning down here, this is not an easy problem. It's definitely medium. You might even call it hard. Hey, dude, I just got an entry-level front-end job. Congrats. Congrats. Okay. So we have this O of n time complexity target and this O of 1 space complexity target. So what do we want to do? We want to do a few things. 1, find the midpoint. 2, flip the list from midpoint to end. And 3, compare head to end on first half and second half of the list concurrently. That's what we want to do. Okay. So fast is head, slow is head. We can also say if not head, return false. So get rid of that case. This thing says optional up here. So let's just guarantee that we have a head node, okay? And here we'll find the midpoint. Using slow. So fast is going to move twice as fast as slow, so that when fast hits the end, slow is at the middle. Fast is moving twice as fast because we're iterating twice. Dot next, dot next. That's why we have it there twice. If any of these are none, we've hit the end. If any of these are none, we've hit the end of the list. And we're guaranteed to eventually hit it, so I don't need to deal with the case where there's a cycle. I think you're doing the solution for finding the midpoint of a cycle, not a cycle. Oops, sorry. Yeah, no, my head skipped to the palindrome problem. Thank you so much. Gosh, this is the danger of autopilot. So what am I doing here? I just want to know if you have a cycle. I do want fast and slow. If not, head works. JK, don't do this. So we don't want to mutate the list. Yeah, I can use a cache. The harder thing to do is use fast and slow pointers. That's it. So it is O1 space complexity. Okay, otherwise we're good. That's not, yeah, we're not guaranteed to not have a cycle. we can have cycles for sure. It's kind of the point of the problem. Okay. So in this case, we're going to go ahead and increment fast. So fast is fast.next.next. And we can also increment slow. So slow is slow.next. And then if fast is slow, return true. Collision means someone got lapped. So a loop exists. It's a by ref comparison. Does that make sense? If we get down here, return false. That means we exited the list. Full stop. If you exit the list at all, there's not going to be a loop. But also you exited the list without having a collision. Okay, cool. Ta-da. All right. So that's how we figure out if there's a loop at all. Now let's go figure out if there's a palindrome. So what's a palindrome? Mom, dad, race car. It's the same forward as backwards. The number 11, the numbers 121 and 22, not the number 20. It's not symmetrical, you see. Every single digit is going to be a palindrome. Every single letter is going to be a palindrome. Papi Sensei, what's going on? Thanks for being here. Go ahead and tap like on the video if you're getting interest, fun information out of the video. That'll help the algorithm send it around so other people can learn too. You can also sign up at latterly.io for free, join the Discord, and we can help get you prepped for interview if you're interested. Or if you already have a job, maybe we accelerate you to senior level, get you a promotion, something like that. Maybe get you a new skill. Okay. So we have the head of a singly linked list, and we want to return true if it's a palindrome, false otherwise. And here we have a couple examples. We must explore every node to see whether it's a palindrome. So time complexity is O of n. And I like to call it target time complexity. So we like to use tentative language. That way, in case you fumble, you don't look dumb. So target time complexity. And you can say worst case. You can say it's your target worst case. But don't say the worst case time complexity is. Don't say that. Say my target worst case time complexity is. Okay. And what about space complexity? We can cast to array or string, then compare entity equals entity dot reverse. That takes O of n space complexity. Fast and slow pointers are O of 1 complexity, and they work too. Implementation is more complex. We need to flip the second half of the linked list. So let's do that. Here's fast, here's slow. We'll say while, kind of like the same loop logic we did, while fast and fast.next and fast.next. Next. This one, it's interesting to note that we're guaranteed not to have a cycle. We're eventually going to return false, it's not a palindrome. We're eventually going to return true, it is a palindrome if we get this far. So while so here we're going to find midpoint. And then here, we need to reverse second half of the list. Okay, so we need to do those things. And while once those things are done, we'll be able to consider the word dad. We flip the second half. So it's DA versus D and then a none or a null or an empty space. So you can point at the D and then you can point at the next letter. And as long as you treat like empty is equivalent to any letter, you're going to be good. Dad, mom, race car. Race car might make more sense. So you take race car and you can see that the R's match. You flip the second half. The R's match, the A's match. And then what happens after that is maybe not so important. The trick is going to be this while A and B. So if either one falls off, we just exit the loop and return true. So that's how we're treating the last letter as like a free pass if you're comparing any letter to an empty value. Does that make sense? Okay. If first half node dot val, and I think it's val, not value, right? So they're going to be called val. If it's different, it's not a palindrome. So there we're doing the incrementing. Again, this is assuming that we already have these things. So first half node is head. We just start it back at head. And then second half node is reverse linked list of slow. So the slow one is going to be at the midpoint, and then that midpoint starts the second half. So we're going to pass slow into a reversal, and it'll be the head of the reversed one. Make sense? So I still need to do these two things. So let's find the midpoint, and then we'll build our reverse linked list function. To find the midpoint, we want to say, okay, fast is fast.next, and slow is slow.next. I think that's it. So fast is going all the way through the list, and slow is going to end up at the midpoint. Great. Let's put this on the solution class, so it'll be on the same class. So we'll use the .self. Call this rev head. So it's the head maybe that's not a good name. I don't know. Let's implement this and I could think about it. This could be useful if you'd stop conflating the palindrome problem with the cycle problem. What did I conflate? Just because of fast and slow pointers? Is that what you mean? It's a similar pattern. I didn't mean to conflate anything. Okay, so here on my current node, I'll be pointing at my next node, but I want to reverse that. So the next node points at me, and I point at my previous node. So previous is going to be none. Because that's what it would be if I went all the way to the end, and I got to my last node, and then I said, what's the next thing? It would be none. It would be none, because you're out of nodes. So I want to reverse that, so that now my first one, instead of my last one pointing to none, I want, instead of my first one pointing next to none, I need to say this better. Instead of my last node pointing to none as the next iteration, I want my first node to point to none as the previous iteration. That's the inversion. I think I got it right that time. Okay. So while rev head we want to reverse that, and then I want to return. What do I want to return? I'm going to navigate all the way down this list, and I want to return the last node, not the last value, because the last value will be the none. I want to return the last actual node. So I want to return priv. Thanks for the follow. Okay, so here, let's cache cur for mutation. Let's cache cur for mutation. Cache cur to separate, to allow safe mutation without creating a cycle or navigation problem. So cur is rev head? No, that doesn't make sense. Cur cannot be rev head. Maybe I need to sign cur out here. Cur is rev head out here. While cur. I think this might be right. Okay, So cur is rev head out here. And then we want to cache cur. We don't want to cache cur. You can do it either way. You can cache cur, but if you cache cur, it's going to become prev, which is going to override none. We don't want to override none before we use it. So let's cache next. Let's cache next instead. Cache next to allow safe mutation without creating a cycle on cur.next. Does that make sense? Because if I flip it and then I say next, it's going to come back to me. So I need to do like a temporary variable and cache it, cache the reference, so that I can do the mutation. I can do the mutation after I have navigated. Cache next to allow safe mutation after navigation. So we don't build a cycle. I think that's a simpler way to say it. Why is next yellow? That's weird to me that it's yellow. Oh, because that's a method name. Next node, how about that? Okay, so next node is going to be cur.next. Okay, then we're going to do some flipping, and then cur becomes next node. And then we iterate from there, because then we'll ask the question, is next node present or is it none? Does that make sense? Okay, so here, now my next is cached, so I can break next safely now. So now cur.next, let's break it, and we'll say it's prev. So I'm going to say, now that I've safely got my navigation where I can pick it up where I left off, now I'm going to say, hey, where I would go, let's flip that. I'm pointing back at prev. Do I need to do anything else? Linked lists go crazy. What's up? What's up? So on even linked lists, you stop at the left node from the middle. Let's see. In the even case, let's say 1, 2, 2, 1. Let's look at this case, 1, 2, 2, 1. So fast, so they both start on the 1, right? And then fast is going to say next.next. So fast comes over to the right hand. No, it'll be starting on the right. No. It'll hit the right. Interesting question, but no, it'll be the right hand of middle. It'll be the right hand of middle. What is the problem number? We're on 234. By the way, if you're on TikTok, thank you so much for being here. And you can go to my bio and see the full screen with the YouTube or Twitch links. Thank you so much for being here. Slow is the midpoint, so it's the left 2. Oh yeah, let's see. I think that's a good call. So fast will point to, the right 2, but slow just went up to the left 2. Yeah, okay. So maybe I should just do this. Hold on. Fast.next. Does that fix it? So now fast is going to here. Fast.next, and then fast gets set to none. I think that probably fixed it. What do you think? We'll come back and test it at the verification step anyway. Yeah, this might be better. Thanks for the comment. Okay, so here is where I'm focused on. I think I'm missing a line. Maybe I'm not. Maybe this is fine. So while we have a node, okay, we're going to say, hey, let me store where you're going. And now I can safely break your next. So now you're going to point at priv. Oh, I need to reset priv. That's what I'm doing wrong. Okay. So cur next points at priv. Now that we changed that association, now I can reuse priv to be cur. I think that's the bit that I was missing. All right, let's check this out. Looks like a fun problem. Yeah, it's pretty fun. If you only checked, oh, Fred Jones says priv never changes though. Yeah, I think you caught something that I was missing. Ooh, this looks like it's going to time out. What's taking so long for? That looks like a fun problem. I think so. Thanks for the follow. Who is this? Catalogist. Catalogist. Thank you for the follow. I think you have to break the two reversed lists. No, I don't need two reversed lists. I only need one reversed list. Might just need to refresh the page. To do reverse second half of the list. Okay, I think I did that. Tail from the left list still points to the end of the reversed lists. Did I never set priv? Next node is cur.next. It says hold on. It says unknown network error, try reloading page. So I'm going to try that. Got a pretty active comment section. That's great. I'm sorry if I'm not keeping up with all your comments. Yeah, no, it worked. It wasn't an infinite loop. It was like some kind of a network error. So we break the list on priv. You see that? First iteration, it will end though, because cur.next, and thus cur will be none because of priv. What are you saying? First cur iteration, it will end. While cur. No. Yeah, the piece that you're missing is this next node. So we cache the next node and we basically teleport. It's basically like, this is pretty much teleportation. Does that make sense? So we build a cycle. I think what you're saying is like, dude, you built an infinite loop. Didn't you build an infinite loop? It's kind of like, yeah, except then we teleported out of it. How often does this live happen? Monday through Friday. All right, we got to win. Well, let's get to what we're actually here for, which is some BFS and some DFS. Omnish. Hopefully I'm saying your name correctly. Thank you so much for being here on YouTube. By the way, I hope you'll tap the like and subscribe buttons. So Omnish says we can also use fast and slow pointer approach. Omnish, that is exactly what we did use. We did use the fast and slow pointer approach. Okay, so I'm going to wipe out this DFS. And I'm going to wipe out this line. I already saw it. Oh no, my mind is burned with the truth and I can't unsee it. Let's read the problem. Clone graph. So if I give you a reference to a node in a connected graph, it's undirected. If you have a little bit of dyslexia, which when I read too fast, sometimes I'll invert words. A connected undirected graph is totally different than an unconnected directed graph. I think it mostly doesn't matter that it's an undirected graph. Maybe some computer science professor will come beat me up for saying that. But I think the thing that's important to know here is that it is a connected graph. Juan says, you confusing me. A connected graph, look at the picture. That'll make more sense. So there's no circles floating on an island. The whole graph is connected. You have the ability to reach every node from the starting node. That's the thing that's really, really important. Otherwise, you cannot use DFS. Or at least you cannot only use DFS. You would need to combine it with some other techniques. DFS uses recursion, which is going to require that I can touch every node in the graph from my starting point. That's a requirement for DFS. Because DFS, recursion, we're just calling the same function over and over and over. What function can I call that will allow me to visit an unconnected node? Okay. So let's say that you have a node in a connected undirected graph and you want to return a deep copy. Omnish says BFS is best for that. He's right. That's one you can do. If you have a disconnected graph, you can likely still use BFS. You can likely still use BFS. Okay. Return a deep copy of the graph. Deep copy means every node is a new instance. So you're not referring to any existing instance. That's why it is a deep copy. As opposed to what we call a shallow copy. Your shallow copy can be a collection of pointers. That can be a shallow copy. So shallow copies are cheaper, but they have missing benefits. They have missing benefits also. Typically, I want to make a deep copy so I can mutate it without hurting the original input. That could not be the case if I only have a pointer collection. Colin, thank you for the follow. Okay, so here's an example of the interface. It's going to have a value and a list of neighbors. For the test cases, each node's value is the same as its index. That's interesting to know. So we are going to get the index here. The given node will always be the first node with a value of 1. You must return the copy of the given node. So whatever node I return, the top node needs to have a value of 1. So don't start with like zero-base index, something like this. You start with the value literal. It should always be 1. Okay, that seems fine. And it's possible to have an output list. This one is strange. This one is strange because it gives me a node and it says the output is empty. I think that's a syntax problem. I shouldn't be returning a list anyway. I should be returning a node. Okay, it's just the list of neighbors. This is like a misleading format. So I'll be returning a node who has a list of neighbors that is empty. You see here, this is the neighbors list, only it's showing. Okay, I know what it means. That's confusing though. All right, so, and now I cheated even more because I see I have this hash map. Whatever, I didn't mean, let me move that down so next time I'll wipe it out better. No, actually it's good for it to be out there. So I'm going to clone this graph and I want to use DFS. Let's talk about the complexity first, time complexity. I must explore every node to build a deep clone. So target TC is O(n). Now that means every node, but my nodes can have multiple connections, edges. A graph with many connections is slower than the same graph with one edge between nodes. And it's non-linearly. It's non-linearly slower. That's the key. Because it's non-linearly slower, we must account for it in the asymptotic complexity. Amnish says, I'm trying to use the BFS algorithm. Nice. I'll be using DFS, then I'll come around and do BFS. We need to account for it. So target TC is O of V plus E is the typical way we say this. Okay. And also, space complexity is also O of E, because I must copy all nodes. So I think that does it for the complexity. DFS and BFS both have same complexity. BFS uses a queue, while DFS uses the call stack for the same space. I'll use DFS. If I'm in the interview, what I will say is I will try DFS first. So that way it's non-committal. You see how I'm using tentative non-committal language? I'll try DFS first. That way, if I fail, I can switch over to BFS. So I'll say I'll try DFS first because I think it's more concise. Is this Java? Nope, we're using Python. You can see that right up in the top of the window there, Python 3. Amnish says, so I'm using the queue and create a hash map of original node and the new node. It's perfect, man. Great job. Great job. That's the right idea. What I'm doing is the different case. So here I'm just going to return DFS of node. Just going to return DFS of node. I need to go implement the DFS. What I also need to do is account for the none case. So I'll say if node, else none. That's it. That's my whole implementation. So now let's go here. And I'll return DFS of node. If node, else none. Chandu on Twitch. Hi, Chandu. Thanks for being here. Fred says, where else are you streaming? Let's see. TikTok, Twitch, YouTube, LinkedIn. I think that's it. If you'd like to see the full screen, head over to my bio and you can check the YouTube link. Also, my streams are saved on YouTube as well. So whenever the stream is done, you'll be able to go replay it. So that's another reason YouTube is kind of goated. How weird is coding? I'm with you. Okay, so this one is not correct. Amnish says, love from India. Thank you. Same to you, but from United States. How many viewers? I don't know. What's it matter? Looks like 20. 20. I'm not a famous guy. I'm just a coder. Okay. So what's wrong with this? Because this is not right. What we need to do is we need a escape. We need to build an escape. So calculate if needed, store if calculated, and escape if pre-calculated. If we follow that protocol across the graph, we'll calculate every node. If we check the neighbors. Calculate if needed for node, store if needed for node, escape if needed for node. I think that's still the right protocol. But what does it mean, calculate for node? Check the neighbors. That's what it means. So calculate if needed. The way that we know this is because whether or not it's cached. So now I need to use the process node map. If foo in process node map. So foo is node dot value. Is it val or value? It's val. We can just look it up like this. If the node is there, we return the one that we already did. So we're not duplicating work. Okay. Otherwise, we're going to come down here and check the neighbors. We will store. So we're going to say this is to do. And then the escape, we don't need to separately write because it's just right here. I like the sound of your keyboard. Thank you. Thanks for the follow. Oh man, this is way better than TikTok. Thanks, Fred. Hey, Fred. Thanks for being here. Okay. So, like this is wrong. What do we actually want to return? I want to calculate the neighbors. That's exactly what I want to do. I keep saying it, but I don't do it. So for in node dot, am I spelling this right? Neighbors. What I want to do is run DFS on in. And then I want to say like calculated neighbors is this array. And then I will say calculated neighbors dot append cur. So I'll append cur. Now I have all of my calculated neighbors. Here I'm going to say process node map. Nope, sorry. I'm going to say node. Is that where the neighbors go? That doesn't seem right. Oh, I need to actually make my new node. I need to make my new node. So we're going to return new node. This is the deep clone. Okay, that's the piece that I was missing. So new node is a node. Let me go make sure that this needs to get, okay, it's already there. So new node is a node. Node has a value which is equal to my current value. And it has neighbors, which I've just spent so much time caring about because we love our neighbors, dude. You know what I mean? Oh, now the blockchain Python. Are you reading code? Well, we're writing code, but I guess you have to write it before you read it. How do I get this good? Practice, practice, practice. That's all it is. So check out laterally.io. You can sign up for free. This is on the blog. This is the Laterally Leetcode kata. It's just practice. That's all it is. I promise you. Thanks again for being here. Feel free to tap the screen if you're getting any value out of it. Earlier, someone asked how many viewers we were at 20. Now we're at 40. Go team. Thanks to you. Thanks to you for helping share the video, like it, follow it. Whatever you're doing is working. I guess I don't know if the comments help too. I don't know how algorithms work, y'all. I'll be honest. Okay. Mobby says no value. Oh, bummer. Bummer. You can sign up for free at the Discord. You want some value? I'll show you how to get some value. You can go to laterally.io, link is in the bio. Go over here to the community tab, join the Discord. And after the stream, whatever questions you have, just come drop them. You'll have a whole group of people coming to help you. By the way, Laterally is open source. If you want to contribute, do a feature request, bam. If you don't get value out of that, I don't know what to tell you. That's called a steal. That's a good old-fashioned steal. Mohammed, thank you for the follow. Mac Daddy, algorithms? Yes, it is. Yes, it is. Okay, so here's the deep clone. Now we have this value. Is Laterally for beginners? Yes, well, it's for any stage. It's for any stage, but it is very beginner friendly. Can you please tell me time for live streaming? Because I am from India. It is 1:24 at night. The stream typically starts about an hour ago. The stream typically starts about 1 hour ago. Some days I do another stream, which is 5 hours from now. So I guess it will be, by the way, there's more than one time zone in India, right? Is it only one time zone? Wow, there was only one IST, really? I thought there was more. Well, anyway, so I guess it will be like 6:30 in the morning. That's not great for you either, is it? Sorry. If you get a large group of people and if they say we prefer this time, I'll do almost any time. So get all of your friends together and say this is the time that's best for us. Also the Discord itself, right? Discord, you can ask a question anytime. Okay. Here I have a new node. Here I have a new node. Calculated neighbor. We ran the DFS, we append it. We made the new node. We cached the node, we return the node. I think it's good at this point. Let's see. Let's see what all the things I got wrong. Oh, okay, I have an infinite loop. That's no good. Let's see. Why is this DFS not allowed? So the neighbor is a node. Because my cache condition is node.val. Node.val is new node. Still seems okay. Did you set a stop point? No, not yet. Written, thanks for the follow. Yeah, we might need to do some breakpoints here momentarily. Let me just read it a bit first. So we're getting down into here. That's kind of a green flag, actually. So we're getting down into here. And now I wanted to do a DFS on you, for example. I think I'm not returning none. That's why I can never break. If node.val in so if it's cached, we do this. What is my none condition? If you have no neighbors. Yeah, I think this is probably bad. I think here I might want to return none. Let's see, I'm not sure if this is right, but let's try this. So if you have neighbors, we'll clone you. But if you don't have neighbors, I'm going to return none. Is that true? When I said no value, I meant only for people who want to start encoding. For others, it's a value. Oh, you should go check the checklist. So go to latterly.io, sign up for free, and then look at the standard checklist. This is like step by step how to learn to code. If you don't know any code at all, check that out. Benny says, can you show the question? Yeah, it's clone graph 133. Okay, so what if I do this? If you have neighbors, then we're going to calculate the neighbors. Cool. If you don't have neighbors, we're returning none. Feels bad. That seems like a bad idea. Yeah, that's a bad idea. Let's see. The problem is that I'm not obtaining none, but I'm not understanding the condition where I want to obtain none. Oh, let's see. This needs to be none in some cases. Nope. Okay, we're going to look up the solution. Let's do that. What did I do wrong here? So this worked in the past, and what was my solution? Clone is the node value. Clone.neighbors.append. Right. I'm not super sure why that matters. Okay. So what I'm return, if it's in the process map, we return it. Great. Oh, we need to eagerly put it in the map. That's the problem. We need to eagerly put it in the map. Because it's never actually getting cached. We're getting into an infinite loop before we cache anything. The way that we can escape the infinite loop is by eager caching. So check the neighbors. We actually want to eagerly cache before calculation, so we don't get an infinite loop. Okay, so how do we eagerly cache? We say that the new node is a node that has the value of node.value. Cool. So now that we have an eager cache, anytime we run into that node again, look on the description. You see how 1, 2, 3, 4, it's a full circle. So there's a cycle basically. You have like 4 is pointing at 1, 1 pointing at 2. So we need to let that be okay. And the way that we can do that is by putting a cached value on the node. So my call stack doesn't grow. It's like, okay, that's already being handled. It's already being handled. KB, yo, happy Friday. What's going on, KB? Good to see you. It is Friday. I forget that, don't I? Sometimes when you're on the job search, honestly, you don't feel like you get weekends. But I'm not taking tomorrow off. Like I'm working tomorrow. I'm job search working. Hey, it's still work. It's still work. Let me assure you, it is still work. But here's what I am doing. I'm going to take off my Sunday for sure. Those are sacred. You need the rest. And then Monday's a holiday, so I'm going to take that one off too. I might do some light stuff, but it's not going to be a tough day. Robe, AI is going to replace you. It can't come quickly enough. Can't come quickly enough. I'm with the family this weekend. Excited. Awesome. Okay, so now we're doing this eager caching. By the way, y'all should go follow Robe. No, just kidding. Actually, I'm not sure I know who that is. Robots building education. There's a different guy, Robe. This guy. He also goes by Robe. Copy all that code and put it in ChatGPT. No way. So now I don't need this. So here we have the eager cache now. Oh, at least we don't have an infinite loop. So what happened? You must return a copy of all the nodes in the original graph. No, there's no way. There's no way. That was good. This is good. What is this? Andrew says, how much do you earn in a month? Like 0 right now, because I got laid off. My total comp was like 370 before I got laid off. Okay, so why is this not working? Where did you work? A company called Upstart. It's a fintech. So, I know what I did differently. I guess I'll rewrite it just for kicks. I know what I did differently, but I don't know why it matters. So what I did differently is for n and node.neighbors. And then here I just directly appended it. New node dot neighbors dot, oh, okay. No, let me just write it and we'll see. I just directly appended the DFS. It's still wrong. Okay. I'm actually relieved by that because I don't understand why that's any better. Although it's cleaner, but still. Save some time and put it in AI. No, that doesn't save time because the point is to pass the interview and you're not allowed to use AI during the interview. So that doesn't save time. That creates a crutch, which will not help you in a coding round. Okay, so let's look back up at the solution. For child in node.neighbors. The difference here is not clicking for me. Let me grab this. Is it just because it's not on the solution class? That would be weird. I'm going to literally paste this. Okay, so there's some difference in the implementation. Let me indent this. We'll call this old. It's not catching my eye somehow. Okay. When you include the function within itself, you don't need self. Yeah, I know. So the difference is not self. The difference is not self. There's something in the way that I wrote it that's different. Here I'm caching node val. Okay, it's because I'm caching off of the node versus the value. Why does that matter? Why does that matter? Process node map of clone. That's the real difference. Process node map. What if I go like this? So here I'm using the value as the key. Instead of a node key, I have a primitive key. And that's going to be wrong now. Node with value 2 doesn't exist in the original graph. Explain to me binary code in dumb form, please. I'm ITF and I can't get it. I don't know what ITF means. Binary code is a collection of ones and zeros. They're essentially true-false statements. A 1 or a 0 is called a bit of information. It's either true or false. Basically, all information can be represented as a series of true-false statements. So I can ask you the question, is this the letter O? And you can tell me yes or no. I could go through the whole alphabet. Is this A? Is this B? Is this C? And so eventually you can figure out what letter it is based off of a collection of yes or no questions. Then I can also ask you, is this the color red? Is this the color blue? And eventually we get to yellow. And so you can find that this is a yellow letter O, and this is a yellow letter L, just by looking at a collection of true-false statements. So this is the alphanumeric representation, and binary just has a bunch of ones and zeros that represent that same display on the screen. Pro Knowledge, thanks for the follow. So what is the difference here? Okay, using the value as a key seems to have created a problem, and I'm not sure why. So if I get rid of these vowels, it basically is going to work. Yeah, it basically works. Now, if I prepend this with val, that's fine. And then it also doesn't matter whether, I don't think it matters whether I append neighbors right here. For child node and neighbors. So node neighbors equals calculated neighbors. New node is not defined. Okay, because now it's called clone. Okay, so it still works. So the problem is the key. Why is that happening? Node with value 2 doesn't exist in the original graph. Just could be a LeetCode weirdness. That's not helpful. They're doing a totally different thing, actually. This happens because you mutate the input graph. Did I mutate the input graph? I didn't mutate it. Like, the difference is just the key. Well, I don't know. But anyway, this works. In some ways, it's nicer because the node is hashable. So even if the values vary, you still have a unique ID to the object. Great, that's cool. It's a better solution in that way. I really wish these things had I really wish this worked though. Like, I don't see why this doesn't work. Yeah, I'll make a question out of this. Okay, thanks everyone for tuning in. That's going to be it for today. I'm going to take this as a question over to Stack Overflow. We'll see where it gets me. And I'll see you maybe tomorrow or else on Monday.